Now more than ever, innovative technologies are fueling change and sparking new ways of thinking. Collaboration between corporations and startups is key to staying at the forefront of these trends. However, finding the right startups can be expensive, time-consuming, and ineffective. But Plug and Play is here to help. As a corporate partner, you will gain access to a whole ecosystem of innovation. Discover startups that meet your tech interests. Stay updated on the latest trends and network with industry peers. We will help you during every stage of your innovation journey, no matter where you are and where you want to go. Get in touch today.
Okay, hello and a warm welcome to our Innovation Day hosted with the Port of Antwerp, focused on accelerating circular technologies. For the next few hours, we have an exciting lineup filled with keynote speakers, inspiring panel talks, and also exciting Q&As. And before we start, first of all, I would like to thank our partner, Port of Antwerp, for hosting this event together with Plug and Play. We are here in the beautiful Port House, and I think in the meantime, you also realize that this is a hybrid event, which means you are joining, the audience is joining us virtually, while our panelists and our keynote speakers are here live in Antwerp. My name is David. I am the moderator for today's event. I have the pleasure to guide you through the next 2 hours and also through the agenda. Before we kick it off and before you hear from our very first keynote speakers, I'll give you a quick snapshot of Plug and Play and what we do internationally as well as here in Antwerp. So Plug and Play, we are a very small company. We are headquartered in Sunnyvale in California, in the heart of the Silicon Valley. We recently celebrated our 15-year anniversary, and we basically started as an early stage investor. And one of our lucky investments we did back in the days was companies like Google, Dropbox, or PayPal. But fast forwarding to today, we were able to really create an ecosystem with several important stakeholders. Most important stakeholders in our relationship are always startups and corporations. And in between, you have VCs, governments, mentors, and regulators. What we do in a nutshell, basically we have 3 main pillars of activities, what you see here on this slide. On the left-hand side, our innovation platforms, this is what we operate in over 60 locations in the world, focusing on very specific industry-related topics. So we have topics focusing on healthcare, on real estate, on energy, and of course also on maritime. The second part, corporate innovation, this is what we do. That's our business model, our services we offer. We help major corporations along their innovation strategies to help them get in touch with startups, but also in the entire end-to-end innovation process. The last topic is our venture capital activities. Plug and Play is one of the most active venture capital companies in the world, not measured by the number of investments, or it's measured by the number of investments, sorry, and not by the amount of investments. So we usually invest in very small and early stage companies, and we usually participate in their growth over the following years. If you have a look on our physical presence, so again, as I mentioned, we started in Silicon Valley, and in the meantime, we expanded into lots of different locations in the world, usually together with strong industry partners. So we have a big and strong presence in Europe, but also in Asia and the US, and we launch offices always together with our partners who join us on the journey in the innovation ecosystem. I just mentioned the industry-specific activities, and this is what you can see here. So Plug and Play has dedicated programs focusing on brand and retail, on healthcare, and our newest addition since the middle of last year is our maritime practice, and I will show you a little bit more about that. So Plug and Play Maritime was established in summer 2021. We landed here in Antwerp with our founding partners, the City of Antwerp, the Port of Antwerp, which we're happy to co-host this event together with. Then we have CMB, DXC Technology, Euronav, and also the MCA community as our partners on the platform. We started with our first batch, so the first startups are into the very first program, working with our corporate partners along, for example, pilot projects, and you're able to see the outcomes in our first Expo Day in June. What you see here are our focus areas for this platform and for the activities. Of course, I'm not going too much into detail here, otherwise we lose too much time, but of course we address topics which are relevant for the entire industry and beyond that. And of course, today, I think especially the green pillar here, the sustainability side, is something which we also hear and talk a lot about today. We have following a short video about our activities and our summary of the year 2021. It's a 1-minute video, and after that I show you the agenda, but let's switch over to the video. Okay, let's have a look at the agenda for today. We started already with an introduction, a welcome, and now the first point on the agenda is an introduction on the NextGen district from an initiative from the Port of Antwerp. I'm very happy to have Marleen and Erik here on stage in a second. Following this, we have Jan Mertens from ENGIE talking about why carbon neutral energy transition will imply the use of lots of carbon. Following this, we have a quick Q&A with Jan, and then following this, we have Erik from Indaver coming on stage and talking about the molecule management from an Indaver perspective. After that, we also have a quick Q&A with Erik, and then we have, before the break, a keynote from Babette from Lanzatech talking about capturing carbon and creating value. Following the break, we will move into our panel discussion, and I'm excited to have exciting panelists with me from the Blue Cam, but also from Triple Helix and from Total Energies. And after that, we hear again for our closing remarks from Marleen and Pete from the Port of Antwerp. And with that, without losing too much time, I invite our very first keynote speakers for today. And Dries, I would like to welcome you on stage for an introduction on the NextGen district. Thank you so much.
Very much, David, for this kind introduction. Yes, together with my colleague Marleen, I will give an introduction on NextGen District and NextGen Demo, project on which we are together with an entire team working on the business development of. So NextGen District, maybe start with a small helicopter view of what we are doing as a port authority with the Port of Antwerp. So we have an entire roadmap, a big challenge in front of us with climate change heading towards a CO2 neutral economy. And we are doing this, and we've created here for a pathway where we are working on 3 pillars to achieve those goals. The first pillar is sustainable energy, working with renewables. A second pillar is sustainable industry, working together with the industry platform to, let's say, step by step from fossil fuels and go into working also as well with renewables, thinking about green hydrogen, thinking about circular economy, etc. And a third one is sustainable shipping, where you see an example here is that we have 16,000 seagoing vessels coming in and out of the Port of Antwerp on a yearly base. This also is a huge transition to be made in the next year, thinking about bunkering those vessels. Today, again, mostly on fossil fuels, thinking about methanol, ammonia, etc. towards the future as alternatives. Now, with NextGen District is a part of this industrial transformation and is a zone inside the heart of the Port of Antwerp that we've foreseen dedicated for circular economy. Now, circular economy is something that is commonly used, and if you're a good salesman, you can sell everything as being circular economy. That's why we've set a very dedicated focus on what do we understand as Port Authority of circular economy, and how do we translate this into action at NextGen District. And this focus is actually twofold. That is twofold. The first one is based on process industry and 3 subdomains there. So CO2 activities, capturing CO2, and of course also using this CO2 as a very important cornerstone in our chemical network to create new materials. Second domain is bio-based activities. So again, here stepping away the fossil feedstock fuels and going into bio-based fuels, as there is, for example, agricultural waste. And a third domain is mechanical, and especially for Antwerp, very interesting, as we've seen when we were doing the development of NextGen District, is the chemical recycling of plastics. Different kinds of plastics, but you can then break them down into base chemicals, reintegrate them in our existing platform. The second axe is based on manufacturing industry, and here we are looking more into energy transition, and some examples here are, for example, hydrogen economy, fuel cells, electrolyzers. This will be also and play a very important role in the near future. So that is also something that we want to attract on the platform and have them accelerated here so they can find their way inside our cluster. Now, to go in detail on NextGen District itself, so it's a physical part of the Port of Antwerp based on the right bank of the River Scheldt, and that's exactly where our chemical cluster is mostly based. So, for example, in the north you have BASF, down south the refineries of Total and Exxon. So again, here NextGen very in the midst of this important cluster. 88 hectares big. It used to be a plant of General Motors, so cars were manufactured there. Now all these buildings are completely demolished, and this is an image of how it looks like today. There already have been some changes made, but now it's a greenfield area that we are starting to develop. So what are we going to do there is actually create a district, and this is an overview, and it's made up in different zones. One of that is NextGen Demo. I will not be talking about NextGen Demo now. Marleen will do this within a minute. The next one is NextGen Park. That's right next to NextGen Demo. These are lots between 1 and 2 hectares, really looking into technologies that have their first commercialized plans there. New technologies again that have on a small scale can find their way. And then next to that, the red parts, the red lots is what we are mostly focusing on now in the first year of the development. And these are actually developed technologies, but also with the new insights on the business, and that can reinforce our chemical cluster that as well have their, be it pilot plans, be it already commercialized scaled plans, second plans on the platform to reinforce our cluster. Next to that, you still see the strategic reserve. Word says it itself. It's strategic reserve, looking and preserving that for the future. And there's one area left that is a common area. But again, here, I think Marleen will also elaborate on that. But this is also an area that we've foreseen to work on shared services. An example here is shared security. Could also be things that everybody needs and needs to install. For example, a weighbridge. That could also be shared infrastructure at the entrance of the site, so you can save costs, but also can save land at the district itself, which is quite scarce in Antwerp and Western Europe. And finally, before I give the floor to Marleen, we are bringing this to life. And last year and beginning of this year, we were very proud to announce the first 2 investments at the NextGen District. And these are 2 companies called Triple Helix and Boulder Industry. Triple Helix, Steven Peleman, will be part of the panel discussion a little bit later today, is a company that recycles polyurethanes and again provides chemicals to the industry. And Boulder Industries is a company that is converting end-of-life tires into different end products like carbon black, pyrolysis oil, etc., that can be reused, recycled over and over and over again. But now for NextGen Demo, I'm happy to give you the word to Marleen.
Thank you, Dries, and hi to everyone who's watching. I'm the project lead of NextGen Demo, and I'm happy to tell you more about it. As you know, we are facing a huge challenge to be climate neutral by 2050. And therefore, at Port of Antwerp, we want to move towards a circular economy. And to do so, we strongly believe there is a need for innovation and industrial proof of concept. And with NextGen Demo, we want to help circular pioneers to bridge the high-risk stage before commercialization, the so-called Valley of Death. We want to do that by providing a location with shared infrastructure, but also by offering them support services so you can focus on the development of your technology, and by creating an ecosystem that forms a strong network where you can make the right connections. So in this way, we technology providers and investors can bypass the typical scale disadvantages when they want to take their project to the next level. And we see NextGen Demo actually as the last step that a starting technology has to take before it can be commercialized. So what does NextGen Demo offer? First of all, it's a physical space with shared infrastructure in the middle of Europe's largest integrated fuel and chemical cluster. It should accommodate about 10 parties with lots of 200 to 2,000 square meters that are available, still depending on the size that's necessary for the demo installation. And it will be an open air test facility where both the utilities and the facilities can be shared between the different demonstrators, but also with the rest of NextGen districts. And its goal is, of course, to reduce the investment cost for the demonstrators. Next to lowering the investment cost, we also want to further lower the threshold by offering assistance with, for example, permits, but also looking for funding and setting up partnerships, etc. And an ecosystem should give the demonstrators the necessary visibility and encourages the exchange of knowledge and resources, not only within the NextGen district, but within the entire port community and beyond. In Antwerp, we are now already actively working on this ecosystem together with Plug and Play, the City of Antwerp, Blue App and Blue Gem. But of course, these are not the only parties that are part of the ecosystem. And in the future, there will definitely be more. So who are we looking for? With NextGen Demo, we're focusing on industrial, circular and carbon smart demonstration projects with a technology readiness level of 6 to 8. And this with a specific focus on bio-based technologies, waste to chemicals and fuels, carbon capture and utilization, and the storage of renewable energy. I mentioned projects because we want to welcome both starting companies as well as larger companies or a consortium of both who want to test and develop their new technology. So something else I want to emphasize is the TRL level when you submit a project proposal. This can be, of course, lower than 6, since we are aware that the setting up a demonstration unit takes the necessary preparation, and we also want to help you with that. So at this slide, the project progress is shown, and we are now in the preparation phase where we prepare everything to be ready for construction. But also very important during this phase is the launch of NextGen Demo, and we hereby call on candidates to submit their project proposal and to express their needs by the deadline of 28th of February. And then based on the needs, we will work with them to provide the necessary facilities and also accommodate them as effectively as possible. So the road construction is expected to be completed by the end of this year. And then it will, of course, depend on how smoothly the construction of the demo installations goes. But we expect to be operational in the first half of 2023. So NextGen Demo supports innovative and circular companies and organizations so they can focus on developing and scaling up their innovative technology, the technologies that can realize the transition to a sustainable port. Do you want to help shape NextGen Demo with your circular demonstration project? Or you want to know more about it, don't hesitate to get in contact with me. And if you're already convinced of submitting your project proposal, please stay tuned till the end of the event where I'll tell you more on how to apply.
Thank you very much, Marleen. Thank you very much, Dries, for sharing us the insights on the NextGen District and NextGen Demo. Before I hand it over to Jan from ENGIE, I would like to also welcome the audience to raise questions during Jan's presentation. I heard there will be a lot to learn and a lot of insights. And of course, it would be nice to later on also get your questions and towards Jan. With that, I would like to invite Jan to come on stage and start his presentation.
Thank you very much. Thank you. So thank you very much. Thanks for having me. My name is Jan Mertens. I'm Chief Science Officer at ENGIE, so leading the scientific department of ENGIE Research, which I'll talk a little bit about. And I'm also a part-time professor at the University of Ghent. So the title may sound a little bit provocative at first, but I'm sure by the end of this talk, I hope we all agree that the carbon neutral energy transition will actually imply the use of lots of carbon. So as I said, 2 slides on ENGIE and ENGIE Research. Then I'll talk a lot about how we see these 3 pathways toward carbon neutrality to end up with some conclusions. So ENGIE has expressed very recently its new strategy and has announced it wants to be carbon neutral by 2045, which a lot of other companies have announced as well, of course. What is quite particular about ENGIE's strategy is that it's not only on scope 1 and 2, so scope 1 being our own emissions, scope 2 being very small for an energy company, of course, the gas and electricity that we buy, but our scope 3 emissions, which today account for 70% of our CO2 emissions, we've announced that by 2045, basically it means that we will no longer be selling any fossil gas or carbon-containing electricity to our clients, to our industrial and B2C clients anymore after 2045. So quite ambitious on the scope 3, which are today 70% of our emissions. We will need a lot of innovation and research to get there, which is why I'm happy to be part of ENGIE Research, where we've got about 900 researchers spread out a little bit around the world. To be very honest, most of them concentrated closely to Paris, and also a large part here close to Brussels, at Labrelec in Belgium, where we do research on these 23 thematic topics. I will not go into the details, but we've got, of course, got a solar lab, a hydrogen lab, a wind lab, but also an energy storage lab, also enabling technologies such as drones and robotics, artificial intelligence, also, of course, life cycle assessment and social impact assessment becoming more and more important. So we've got all this research going on within the ENGIE group, of course, within and with a lot of external partners as well. We're not a technology company. Usually we don't develop technologies from scratch, except on the 2 left, which you see there, the pilots, which is called the Gaia and the solar hydrogen. On green gases, we do have the intention to be a market leader, and there things like IP and patents are of interest. But in a lot of other research topics and pilots, as we like to call them, we work together with these technology developers, with these company in the hope that we can help them mature their technology a little bit faster. And of course, with our ultimate aim is to hand these technologies over to our business units in the hope that it gives them a competitive advantage when bidding for new projects. I like, for example, the bifacial solar testing, which we've been doing at ENGIE Research for about 10 years in our lab in Chile. Well, today this is standard practice for our business unit solar, for example, to use these panels when bidding for large-scale PV projects. There's in Belgium, there is the hydrogen co-combustion in the port of Antwerp, where we demonstrated up to 20% hydrogen co-combustion in a gas turbine at INEOS. We've also got one in battery storage, where we compare large-scale batteries at the power plant in Drogenbos. Enough about ENGIE Research. So how do we think we can reach this carbon neutrality? We think that there's be 3 pathways that will be crucial, and the order is important. And the first pathway, and the easiest one, and the one that we've been doing, of course, since decades, I dare to say, is to increase efficiency. I mean, we've been doing this for a very long time, but still, there are still efforts that we that need to continue to do the same or even more with less energy. Is the first and easiest maybe, but it's still very important. The second pathway that a lot of people are talking about and which we believe is crucial as well, is we should electrify whatever is electrifiable, far beyond just our electrical cars. And this is a graph which I took from a paper in Nature, where they show that it's the y-axis is actually the marginal abatement cost. So how much does it cost to stop emitting 1 ton of CO2, basically, for different industries? And if you see like cars and low temperature heat, well, direct electrification, which is the bottom line, of course, is the cheapest and probably the most sensible way to go forward. Once you get to industries, high temperature heat, long distance transport, heavy mobility, planes, long storage of energy, then of course we need these molecules. So these are the 3 pathways, and the order is really important. So increase the efficiency, electrify, and then what cannot be done by these 2 first pathways, then we should think about using these molecules. With respect to electricity, the good news is we can do a lot. We've proven the roadmaps wrong. This is a little bit of an old figure, but I still like it a lot. If you look at what happened with the respect to the cumulative installed solar capacity, so the figure on your right, the red line is what actually happened, and all the other lines are all the predictions by the International Energy Agency, but even by Greenpeace, which you can hardly call pessimistic with respect to installing solar PV capacity. So this electrification is important, and it's going at a speed which was never expected. And again, even the latest reports are always underestimating how fast this installation of renewable electricity is going, for a simple reason. It's today cheaper to have an electron produced by wind and PV than it is by coal and gas. But as I said, we cannot electrify everything. High temperature heat, long distance transport of renewable energy, long-term storage of energy. So this is a slide which I took from the International Energy Agency, where again, you see the blue part. It's probably the easiest part. It's decarbonizing or making our electricity carbon neutral is kicking in as of today. And you will see actually by 2035, 2040, this will be almost finished. And so the blue part, which is crucial, it's about 35% of the effort of this 36 gigaton of CO2 that we need to get rid of in this scenario by 2070, but we've got other scenarios by 2050. It's let's say, the easiest and the most straightforward, and this is happening. What is a lot more difficult is, for example, the yellow part, where the effort is expected to be the same. But there, of course, the technologies today are not mature or do not see a lot of positive business cases anyway. And so this is why the IEA also expects this decarbonization of the industry kicking in a little bit later. And so decarbonizing electricity is certainly not sufficient, and we need to think about other technologies. And this is, of course, where carbon capture and utilization, hydrogen, and other of these less mature technologies need to help out. Same is said by the Federal Plan Bureau for Belgium. This is a figure which I took from this report published in 2020, I think. This is if we want to make Belgium carbon neutral by 2050. They've got 2 scenarios, a diversified scenario on your left and a more deep electrification scenario on your right, they don't actually differ that much. In the deep electrification scenario, the modeling they did is that they electrified really everything which you can think of can be electrified. But even in that scenario, you see that it's actually the blue part and the darker blue part, which will be the electricity consumed as electricity. The greener part will be electricity being converted to molecules, which we will need for all these processes that I talked about before. So even in the deep electrification scenario, it's clear that we will need these molecules. What both scenarios agree upon is that we will need lots of electricity and lots of renewable electricity, of course, or at least low carbon electricity, because we need to triple our electricity demand or consumption even in both scenarios by a factor 3. So we need a lot more electricity. Large part of it, where we can, we should consume as electricity, I think. But there will be a need for molecules, and this is where we need to have innovation and research increasing at a very high scale. If you talk about molecules, the obvious molecule that everybody's talking about is hydrogen, of course. And I think hydrogen is a great solution, and it has a great potential. And there's different ways. And I will spare you all the colors from blue over green to turquoise over pink. Some people call it fluo hydrogen, if you wish, for it made from renewable electricity. But there are different ways to get access to low carbon hydrogen. And I think where you cannot electrify, hydrogen is probably the first candidate that you think about. The trouble with hydrogen is, I think it's a real challenge once you have to start moving or transporting it. It's a very, very small molecules, and to shock a little bit, you can say that there's no energy in hydrogen, but of course, volume-wise, has a bit of sense, but of course, gravimetric, it's not true at all. But what it is true is that if you want to transport or store energy over longer distances, long time periods, hydrogen is not that efficient. So here on this figure with the lorries, I've tried to illustrate that. If you want to transport 10 kilowatt hour of energy, don't worry about how much that is. You can actually do that with 1 liter of petrol or diesel. If you do it with electricity, you see you need about 27 times that volume to transport the same amount of energy. So meaning that flying electrical planes over longer distances is probably not something that we will see anytime soon, taking into account that aerodynamics of planes are crucial. If you go to hydrogen, it's a little bit better out there to say. If you compress it to 350 bars, which is the second one from the top, you compress your hydrogen to 350 bars, but even then, we still need to move around 13 times the same volume to transport the same amount of energy. If you compress it further to 700 bar, it's about 7 times. We can liquefy hydrogen. It's not impossible. We know how to do it. We're working on it. We've got a research program on it. But today, it's not that efficient yet. We lose up to 35% of our energy content in the hydrogen to actually make it liquid. And the reason for that is, of course, that we have to go down to minus 250 degrees, which is very close to the absolute minimum. So that's why it needs so much energy to make it liquid. And even if we liquefied it, we still need to move or store 4 times the same amount of volumes. So that's why we think carbon capture and utilization. So making your hydrogen react with another atom, carbon, CO2, to turn it into a hydrocarbon, such as methane or methanol or petrol, or even make it react with a nitrogen and turn it into ammonia, actually makes this renewable energy, this green hydrogen or low carbon hydrogen, makes it a lot more easy to transport and store it. And on top of it, we've got the infrastructure to do so. Which is why we think that there was a really need to do this synthetic hydrocarbon. So what we should stop doing is do what is depicted here in a very simplistic figure. I apologize, but I quite like the simplicity of it. What we should stop doing is taking this natural gas or methane out of the ground, burning it in our infrastructure to produce electricity or heat. And then, of course, we've got our CO2 escaping, which we all know what that leads to. I think we agreed that we will still need this CH4, this natural gas, or this gas molecule to do whatever, all the process that I talked about before. So there's no way, we've got no other solution than to actually produce it, synthesize it, using hydrogen, which usually is made from renewable electricity, and water, which you make react with CO2 taken out of the air or via biogenic pathways, or even in a first phase from fossil industry, make it react over a catalyst or biologically, as Lanzatech will explain you in the next keynote. Produce our in this case, synthetic methane, but it could be methanol, it could be ammonia, it could be any hydrocarbon or other molecule. And then, of course, we use it, and which allows us to become completely carbon neutral, as we call it. And of course, the IPCC and IEA have, in their recent reports, all agreed that carbon neutrality will not be enough to reach this 2-degree scenario, and part of this latter CO2 we'll need to store away somehow as well. This is an example of what we're doing here with a lot of partners in the port of ENGIE at Ineos, where we will use and renewable hydrogen and fatal hydrogen, make it react catalytically, chemically over a catalyst with CO2, which in this case will come from an industry as well, and produce our methanol, which we can then use as a fuel, or why not as a feedstock for the chemistry, because it's a C1 a molecule which is very much wanted for by the chemical industry as well. These are the partners that are in this project, and a picture of where the installation will hopefully come soon. This is one of the examples on one of the molecules. It will not be only hydrogen, it will not be only methanol, it will not be only methane, it will not be only Fischer-Tropsch fuels such as kerosene. We actually work on quite a lot of these molecules, since it's clear that it will very most likely the future we will need all of them for different applications. And so, going from research, where we do research, for example, also on power to protein, how can we make sustainable proteins from electricity and hydrogen, over to methane, methanol, and then of course, so this is today no longer also only us, the research nerds, keeping us busy, but this is becoming reality, and we've got bigger and bigger projects being announced worldwide on this carbon capture and utilization. I just added this slide from a paper published last week by the group of Kevin van Geem and Bert Weghausen, because I think for Antwerp, particularly Antwerp, this CCU and this seeing CO2 as a resource is particularly interesting because of our chemical industry here. And I like this figure which they published on fossil chemistry. They called it how they think, or how we think, and I think we tend to agree. We should move away from this fossil chemistry where you use oil, natural gas, and coal to produce all these molecules that we need, going over urea, formaldehyde, over up to plastics, detergent, and insecticides, using green electricity or low carbon electricity at least. We should move from this fossil chemistry over to an e-chemistry, which allows us to exactly build the same molecules, because we will continue to need them. Conclusions. Just a few takeaways. I think in a first step, we must increase this energy efficiency and think more circular. This is this very first step, which have been going on for decades, but just to repeat, because it stays important. The second one, we think electrification is a really good idea, where you can, and we should go far beyond just our electrical cars, but also electrify in the industry what can be electrified. But for some processes, we will need these molecules, and that's where we think carbon capture and utilization will come in handy, and we will need it to actually achieve our goal. If you want to know more, a little bit of marketing, we publish, and this we just published last week, every year a new document where we present our new emerging technologies to watch out for, what we think as ENGIE experts could change, could be a breakthrough. So if you want to know more about this year's the technology that we present, you can download this here and have a look at it. So thank you very much. I will try to stop here, and I hope I'm still in time, more or less.
Yes, you are. Thank you, Jan, a lot for sharing the insights. I would recommend, feel free to join me here for a quick Q&A. And again, I would like to invite our audience to raise your questions. I think Jan touched on a lot of different topics, to share them in the chat, and so we can read them here on our screen. So maybe to start with, I think you shared a lot of approaches, different projects, and also showed that ENGIE is working on a lot of different things. How easy or how complicated is it to prioritize? I mean, is it hard to get like an overview and measure the priorities to start a project, or like what is your procedure to prioritize the overall approach on the projects?
It's a difficult question, and because it may give the example, the impression that we shoot a little bit on everything by showing it this part. But ENGIE has the ambition, of course, to be market leader in this green hydrogen and renewable electricity. And so as such, the final molecule for us, I would not say we care, because we are a gas company. So if it's methane, it's closer to our DNA, of course. So e-methane is at the highest priority of our molecules. But I think, as I said, we will need all of them anyway to decarbonize industry. And since we have the ambition to be carbon neutral on our scope 3, it means we will have to help our clients also decarbonize. And so they will need other molecules as well. So this is why we don't look only at the e-methane, which is closest to our DNA, of course.
Okay, thank you. We'll have a quick look into the questions that are coming in. Maybe we can go up to the first one. So someone is asking, what are the biggest challenges with the power to methanol project in Antwerp? Maybe you can explain the project a little bit and then also reflect on the question.
I'm not involved in that project, to be honest. So this is good news. This is already today led by our business unit. So it's no longer in the research hands. But I mean, I can imagine the biggest challenge would probably be the business case, right? We know the price of hydrogen and green hydrogen. Since this is also the first of a technology, I can imagine the business case is probably not the easiest. So that would be the biggest challenge, I guess, because technically I'm not saying it's proven and mature technology, but we think we know how to do it.
Okay. Let's have one more question. We have here the timeline for e-fuels. So what in general is the timeline and what does it take to bring the price down, in your opinion?
So there again, it will depend on the e-fuel. We see industries like aviation, for example, as I said, they don't have a lot of alternatives except for biokerosene. So e-kerosene is very high on their agenda. That for me is probably one of the most or easiest business cases today because they don't have an alternative and they are willing to pay more for their molecules. Methane, for example, the one that we like so much is a different story because even though the gas prices today are very high, it is a commodity. And so the business case for e-methane and for e-methanol to a certain extent as well is a lot more difficult than for e-kerosene. So probably it will break through on these other molecules faster than on the more commodity molecules. That's what we think.
Okay, thank you so much. With that, we're ending your part. Thanks a lot for joining us today and for coming over. Next up, we have Erik from Indaver, and I would like to invite you on stage. Jan, you can go into this direction. Yeah, no worries. And then I would like to hand it over to Erik.
Thank you. Thank you very much. Small introduction of myself. Erik Moerman. I work for Indaver now for almost 25 years. I'm responsible for business development. Now, maybe a few words on Indaver. Shift to the right slides. It's basically a waste management company. There are many waste management companies. What makes Indaver, I think I might say, a bit different is that we are a waste management company who started basically in a cradle which was owned by the Flemish authorities in the chemical industry. So from the start, we always had a very close connection, let's say, with the chemical industry. The slide you see here shows you some figures. I'm not going to name all these figures, but what is important, I think there's two key messages here. Maybe even three. We are not, let's say, the biggest waste management company, but we are also not small. And we can say that in the market niche of the chemical industry, because we service chemical industry still, we are actually within the top 3 within Europe. So we started in Antwerp and we developed to a European player. The second message is that we like, we and our shareholder, which is Katunasi, we like cash flow. Why do we like cash flow? Because from the moment we are generating cash flow, we can reinvest in assets, and we are an asset-driven company. So we like to build, to design, build, operate plants, and hopefully for a long time in the future with a good economical return. So EBITDA figure you see there, it's like every year it's 20% of the turnover, and turnover is growing every year. So that gives us a good a source of money to reinvest in installations. And I think the third message I want to give here is that we manage a lot of waste, more than 5 million tons per year. And it's very diverse, these waste streams. And dealing over all these years with all these different waste streams, dealing also with all these different companies who are producing these waste streams puts us in, I think we might say, a good position, starting position to start thinking, designing, constructing assets which are really having the aim to circle materials. I think circular economy, it's something that's mentioned in many platforms. It's easy to say those two words. Let's say the circular part is already very difficult, and the economy part in that word is even more difficult, because many of the projects that we are starting or that we already started, we see that the start of these projects, it's not easy to get the figures right. But at the end, we succeed, but it's a big challenge. Second, what is important also is that we see today that there's really a lack in parties, companies who are able to bridge the gap between the waste with all its disadvantages, because waste is it's not a pure product. There's a lot of impurities. It's always something different when you get loads of waste and so on. So to bridge that reality of waste with an industry who is willing to take in materials, but they like materials which are of high quality and very constant also in terms of specifications and quality. And we took up that challenge. So it has been very hard, but more and more we see that we are able to bridge that gap. And companies, they like that. I can say they also like that more and more, but under one very important condition, and that is that you are purifying, really purifying the waste streams. And with this slide, you see basically this is the main principle of a successful circular economy. Or maybe let's say, forget the economy for now. To have material that is really turning in circles, you need to follow this picture on the slide. And that means that you need to foresee an enabler. Enabler, you see it in the middle of the slide. It's basically a process in our case then a plant that we want to build as Indaver, or we have built, and that is purifying a waste stream which today is most of the cases sent for normal waste treatment and not recycled. So that means that it is very difficult to do so, because if it would be easy, it would have been recycled today. Low-hanging fruit is gone. So that means you need to invest in an expensive plant, an enabler, who has one major goal, and that is to purify it up to a high quality end product that you can bring in again into the normal chemical processing plants. And if you do that well, that means that you are not just looking to the waste as let's say a bale of plastics, but you're looking through the pieces of plastics all the way into the chemistry, into the molecules. And they are so diverse in these waste streams. And actually we came up with the name, so because of marketing reasons, Indaver Molecule Management, but that's basically what we are doing. We are managing molecules. Molecules, valuable molecules that we are taking out, and impurities, also molecules that we are trying to destroy or emit, so that you are having a final valuable product which is where you're able to sell it. So I cannot stress it enough, and you see it here also on this slide as the added value. The aim is to deliver high quality chemical feedstock. That's the key word. Of course, if you do so and you're able to substitute fossil-based feedstock with recycled feedstock, there's immediately also a big saving related to carbon footprint. And even that, let's say, installing these enablers and cleaning up these waste streams that today it seems very challenging, I think that it's the new low-hanging fruit to save on carbon footprint. We have some examples. We have examples which are in piloting phase, construction phase, and operational phase. Some of the examples, they are large scale. We talk about investments, 60 million euros is the biggest example I have here on the screen. But sometimes they're also small, very specific. For example, we have a plant on our site in Antwerp that we converted to the recycling of precious metals in homogeneous catalysts. And we saw after some discussions with some of our pharmaceutical customers that they were using more and more homogeneous catalysts because that's related also to continuous instead of batch mode processes. And basically they were in doubt to convert it to these new processes, this continuous process, because they said, yeah, but we will use homogeneous and it's not recyclable. I said, yeah, but it's not recyclable, and why? And we started to study further into it, and now we have a solution for the recycling of these specific catalysts. It's small volumes, high value. The other examples you see, I have some more slides on each of these examples. So I think one project which is very visible these days is the chemical recycling of plastics. Also we are now investing in a plant, and we will have our plant operational in the beginning of 2024, where we will chemically recycle, on the one hand, polyolefins, and on the other hand, polystyrene, and convert them in styrene and in naphtha and waxes. There is a goal to get up to 1 million tons per year. We'll do it step by step. So we start with a plant of 26,000 tons per year, which will actually cost 50 million euros. So it's a high investment for actually a very small plant. But if we are successful in demonstrating with this plant that we again can produce end products which are having this high quality, and that means in terms of plastics, more specifically that the quality of, for example, the styrene that we will produce, that it's food grade. And why is this so important? Because then you really can start talking about a circular plastic. If it's not food grade, you cannot talk about this in this way. And if you can talk about circular plastic, that means that the brand owners, they become interested, that then the suppliers of the brand owners, they become interested, and so on, up till the off-takers of the styrene that we will produce, they become interested. And interest is then translated also in possibility to ask premiums, which we need to go through this very expensive demonstration phase. So here we showed that it works, the contracts are there, and the investment decision is made. If it's successful, we will actually scale up, and we will actually increase the capacity to 65,000 tons, purely then on polystyrene, and we will then be looking also in other plants for polyolefins, which needs actually a bigger scale before they are, let's say, economical, feasible. Here you see a 3D view, picture, whatever, of the plant. It's already very far in design, and we will actually install it on our site in the port of Antwerp. Another example is an example which is in operation. But in a way, I like to give this example because we had some difficult times with this, and I want to explain why. In a way, in terms of technology, it's nothing very special. I mean, it's available technology. What was actually special is that we brought different comparable waste streams from different from the same type of industries of different customers together, and we pooled them up into a plant. And with these streams all together, we were able to have a business case which was positive. If we would focus on one stream from one customer, we would never be able to make it a positive business case. But we were able to combine, we get all the contracts, and whatever that actually was coming out of this plant was produced, and that is actually two things, which is steam, high pressure steam, and also hydrochlorinated waste, HCl. Not waste, sorry, hydrochlorinated, just HCl, 33%. That basically we were able to sell. And we made contracts for the offtake of both of them. However, around 1 year before we should start up the plant, the offtaker of the hydrochloric acid, they became bankrupt. So no offtake anymore on that spot. And we went on that location. One of the reasons was because there was an offtaker, because we wanted to close everything. And the offtaker was gone. However, we are now actually in operation for a bit more than a year. And luckily we were able to sell the hydrochloric acid, not one offtaker, but a few of them. Maybe that's better than just one in terms of spreading of the risks. And why were we able to do it? Again, the same thing, the quality. The quality is right. It's technical grade hydrochloric acid that we are producing. And in many cases where they were trying to do this before, they were not coming up to this quality, and then you're stuck. So it's always the same conclusion. Here you see some pictures of it. And then I would like to give one other example of an investment which is now coming up. It's actually an investment that we will do together with the Port of Antwerp, and where we will connect our site in Antwerp, where we have 3 waste-to-energy plants treating hazardous waste, producing steam. Already since the beginning in 1989, we had the first plant. It was already there with the steam boiler. It was not obliged then, but we made the decision that at a certain point in time it would be an advantage to have this. And basically we are now in 2022. Now we have a project, final investment decisions are made, where together with the port, we are investing in a 9-kilometer heat network that will deliver the heat to Boortmalt to a big extent, which is a malting company, I think one of the biggest of the world. And they will take majority of the heat, which is of course important because the other part will actually send it to the city of Antwerp, but there the heat is only used in the winter. So the major share of what we will produce will be taken throughout the whole year. And that's also again the success of the business case. Total investment is 34 million euros. Yeah, it's a bit far away, but I think I'm correct. Yeah, I think that's the most important. Here, another figure which is important is that it will save 80,000 tons of CO2 on a yearly basis. So I think we can say that is quite a lot. And I just would like to end with this slide. And I heard a question just before, how are you prioritizing your projects that you're working on? Let's say as I'm responsible for business development already for some time, in the beginning, the projects that we stepped in were projects because they were related to a very specific clear question from a customer or a stakeholder. And then that's easy. You sit together with this customer, you start discussing, and you make up your business case. More and more, actually, we are driving our efforts and also efforts on a lower TRL. As Indaver used to be a company who only stepped in at TRL 8, TRL 7 maybe. And now we actually are also looking a bit further because of the societal challenges that there are. And I think plastic to chemicals is a very good example. We started in 2014 with this. So it's quite some years that we have been working on this, and we developed completely our own process with our own IP and everything. And that's because we saw that there was something coming. And it was driven by the petrochemical industry. They want recycled styrene, recycled naphtha, and so on. But why do they want it? Because, okay, there's a lot to do about this plastic spill. And also there's legislation, which is there already. And more stringent legislation is coming up, which has a direct effect on the business of these companies. And we learn to see a little bit more in the upfront to see what would be coming. And with this now, we're also prioritizing more and more the efforts and the projects that we are working on. And finally, also wanted to make a link to the Power to Methanol project where ENGIE just talked about, as we are also a partner into that. So with this, I would like to conclude and end my presentation.
Thank you so much, Erik. I would also invite you briefly to come over to me, take a seat, grab the microphone. So we'll ask you a couple of more questions. Thank you very much for the presentation. And thanks a lot for addressing also the question that was raised regarding the prioritization. Maybe follow up, because this was also addressed by Jan in regards to the profitability and the return on invest. I think you talked a lot about investments into things. Is that something you're concerned about, or you which is not an issue for you?
No. Well, me personally, maybe not, but my shareholder, yes. So it's indeed a concern, and let's say it needs a lot of good management and also micromanagement, let's say, within your own company, even to do this step-by-step approach. I don't follow sometimes these excuses of the chicken and the egg thing. To make one big step immediately to invest in a big plant, sometimes that it's just not possible. And then don't start with this also within your company and ask your shareholder for money, because it's still too far away. But that does not mean that if you see some lights at the end of the tunnel, that you keep it warm, and little by little you keep it on the table, on the discussing table also of the higher management and the board. And if you've done your homework right, you start to be able to put things on the table which are convincing, to go one little next step and go for that next step. And you don't need millions for that. And then you show again that it works. And so you go step by step. And at the end, you're able to ask for an investment of 50 million euros. And sometimes, unfortunately, companies don't have the time to do that. They don't give their employees the time to go to that process, because the example of Indaver, the plant in France, it took 10 years before we had an operational plant.
A long time.
Yeah.
Okay, maybe one more question from the audience, because also questions are coming in. We have one tough one. What will be following you the next challenge for advanced recycling in terms of pyrolysis, oil quality versus steam cracking? Is it something you can answer?
We know something about this. So basically, what we are now developing with plastic to chemicals is actually a pyrolysis process. So we know very well or understand this question very well. I will answer with the fact that we are now starting a project with a university in Flanders, specifically to study if we can purify pyrolysis oil up to an input for steam cracking without hydrotreatment. And I presume that the person who is asking this, that he understands me then. Hydrotreatment is a very expensive step that today it seems you still need to convert pyrolysis oil to input steam cracker. But let's say we are not 100% convinced that that is the only way. And we will study further. It needs further study, low TRL level. But we see some possibilities.
Amazing. Okay. Erik, thank you so much for coming and for sharing the insights with us. With that, we will continue with our next keynote speaker, and I would like to invite Babette from Lanzatech coming on stage. And you can move into this direction. Thank you so much. And with that, I would like to hand it over to Babette. Thank you so much.
Thank you and good afternoon. First of all, a little thank you to the Port of Antwerp and to Plug and Play. It's really exciting for an early stage company like Lanzatech to see all the good work that's going on in this part of Belgium, in this part of Europe, and the future potential. And of course, it's a bit daunting for us to hear from the big guys like the ENGIEs and the Indavers, but also encouraging to hear all the CO2 reduction activities going on in the large companies. So many of you may not know who Lanzatech are. We are a very different company. We're an early stage company. We were founded in 2005. So not yet a public company and a very small company. We're about 250 people, headquartered in Chicago for now. But the company was founded in New Zealand by Sean Simpson, who's still our chief science officer, based in the US. And I joined the company about 2 years ago to accelerate our business here in Europe, which is obviously a very important market for Lanzatech, given all that's going on in terms of climate and CO2 reduction. So Lanzatech, what do? We capture carbon from industrial emissions, and we convert that carbon, transform it into value in the form of sustainable aviation fuels, road transport fuels, and chemicals. So related to some of the things that were talked about earlier. How do we do this? We use a biological process of gas fermentation. Many of you know the process of fermentation related to beer or to wine. You have yeast, you feed the yeast sugar. In this process, we feed the catalyst, which is a microorganism, a naturally occurring bacteria, with carbon-rich gases, like from steel and from industry. And I was very glad to hear Jan say that while you have an easy task to decarbonize power and energy in industry, we have a big challenge. So we're focused on industries like steel and cement, heavy emitters, but as I'll say in a moment, also solid waste and residues. So this is the heart of our process. Those of you familiar with fermentation will see in the middle, it's a bioreactor, and that's where the production takes place. Lanzatech have developed a whole family of biocatalysts, and that's the reason why you've got the two boxes, green and purple there, because we don't only have one product or one biocatalyst, we have a whole family. The first one that's been commercialized today and that we're using in our commercial operations in China produces ethanol, and we have developed many downstream products for that. But the purple box represents all the other chemicals that we have already got biocatalysts to produce. And the first of those will be isopropyl alcohol, acetone, as well as products like monoethylene glycol. So this shows really the sort of the beginning and the end of the Lanzatech process. Probably looks quite simple. On the left-hand side is where we capture the gas, we clean it up, we compress it, feed it to the fermenter, where the biocatalyst ferments the carbon and produces ethanol and other products. Lanzatech has a licensing business model, so we have about 1,000 patents granted to date. That surprises some people, but it's basically because obviously, apart from the synthetic biology, which is the development of the biocatalysts, we've also patented the process from the capture of the gas through to the production of the different chemicals, as well as some of the equipment. We started out, upstream, all our feedstocks are waste-based, point source and abundant, effectively pollution. We started out in the steel and ferroalloy off-gas industries because that's a good gas composition for our biocatalyst because it contains carbon monoxide, carbon dioxide, and hydrogen. So we have a source of carbon and a source of energy, and the syngas from the steel, cement, and other industries is captured through the process and products produced. But as we're a licensing business model, we've also continued to innovate upstream on other feedstocks, not just industrial gases, but we've also demonstrated the gasification of municipal solid waste, agricultural waste, biomass, wood waste, Class B wood, as well as plastics waste. And as you can see there, there's obviously an additional step You have to have a gasifier. But at the same time, the syngas that produces goes through our process in much the same way as we process the emissions from the steel and the ferroalloy industries. We also have a process that's technically proven to capture CO2 directly, either CO2 from industry, or we're working now on a government project in the UK with carbon engineering, where we actually take the carbon dioxide from direct air capture. The only difference with this particular process, as you'll imagine, is that we need hydrogen, preferably green hydrogen, and electrolysis. And as we heard earlier, and as we know, both of those are not necessarily economically viable today, but we are piloting that process this year to develop it forward. And we believe that both green hydrogen and electrolysis will become economically more attractive with time. So that's the innovation we're doing on the front end. On the downstream, we've worked for the past 15 years to develop mainly sustainable aviation fuels. And I'll tell you in a moment the very exciting stories where commercial flights have actually been flown across the Atlantic using Lanzatech fuels. But right now, we have 2 plants running in China, and about 100% of the ethanol produced in that China plant is being used for road transport fuels today and being blended with transport fuels in China. The key byproduct is the one that you see there in the middle. It's a bag with a fish on it. And that is basically the spent biomass from the bioreactor, which we dry. And in China today, we sell that as a high protein supplement for aquaculture, for fish food. And the bottom right, perhaps the most interesting part to myself from the chemical industry, is the unexpectedly broad range, I have to say, and I've only been in Lanzatech for 2 years, of applications that global brands and intermediate partners like petrochemical companies like TotalEnergies, we have worked with to develop over the last few years. And that has included the ethanol itself for luxury fragrances, household cleaners, or with downstream processing to running shoe soles, polyester fibers, and other applications which I'll highlight to you. And when we produce polymers in that process with downstream partners, as you can imagine, those polymers can be used to be fed into the solid waste stream and add circularity to the process. So I can't remember who, I think Marleen talked about the valley of death. Many companies of the type and size of Lanzatech find it very difficult to get across that valley of death. We did that in 2018 with the plant you see on the top left there, which is the first China plant. It's a steel mill called Shaogang Steel. A company started in 2005, first plant, a 50,000-ton ethanol plant in China with Shaogang Steel, as you can see. And we've been producing there since that time. So we believe the technology is de-risked. People often asked, are the biocatalysts, are the organisms robust? Yes, they've been running smoothly for the past 3 years. And at the end of last year, a second plant was started up in China. One of the reasons we are now hiring a team in Europe is the picture you see on the top right there, which is actually very close to here in Ghent in Belgium, where our first licensee in Europe, ArcelorMittal, is building the first plant integrating Lanzatech's technology into their steel mill in Ghent. And that will be a 64,000-ton plant. It will be running sometime towards the end of this year or beginning of next year. Obviously, like everyone else with COVID and other unanticipated challenges, it's taken a bit longer than we would have liked. But I think, as the other people have mentioned, we've had to also cross many regulatory hurdles. We've had to raise a lot of money. And that, I think, as the previous speaker said, takes time and resources. But on the bottom there, you'll see the projects that where we can talk about the investment decisions. We obviously have many more projects we're working on than those. But what that will show you is that there are going to be 3 plants, possibly 4 in China this year in 2022. The first plant in Europe, here in Belgium. A plant with Sekisui in Japan that's using municipal solid waste as a feedstock, producing ethanol, and that is moving on to chemicals, polyolefins with Sumitomo Chemical. We have 2 projects in India with refinery off-gases and also with agricultural waste, and a project in the ferroalloy space in South Africa. So our challenge today, interestingly, is not so much to develop the applications. Most people know of our areas carbon capture and utilization. We say carbon capture and valorization. And I'll tell you a little bit about the value of the materials that we've learned from our downstream customers. But we need to build more plants more quickly, which means raising more money, because effectively the demand is significantly greater as we serve both the aviation fuels market and the chemicals market. So a little bit of a picture here of where we started on the left-hand side in aviation fuels. That's our CEO, Jennifer Holmgren, in the red jacket with Richard Branson. That was the plane that was flown from Orlando to London. And the little story is that Virgin hadn't told the passengers before they boarded that they were going to be flying with sustainable aviation fuel. Luckily, all went well. And all the passengers, with the exception of one family, took the flight. But the purpose of that is to say not only have we crossed the valley of death and been commercial since 2018, but that flight was flown with Lanzatech aviation fuel, which is ASTM certified. And the other thing that slide shows is that, of course, we've not worked on our own. And all those names and more down there are actually our partners in the process. Because what I'll say in a minute is not only have Lanzatech developed and patented the gas fermentation process, which I showed you earlier, but also a separate process which takes any source of sustainable ethanol, including our own carbon smart ethanol, and converts it through a chemical process to jet and diesel fuel. So we actually have two processes we're working with. And then on the right-hand side, what you see there is all the applications that have been developed, not all, but some of them that have been developed over the past few years, as you can see, is ranging as packaging to detergents, fragrances, and textiles. So just back for a moment to the aviation fuel part, which is where Lanzatech started. In 2020, in the middle of the pandemic, we actually spun out a company called Lanzajet as a separate holding company. The CEO is an aviation industry expert, and he's building his team, Jimmy Smartzis, also based in Chicago. As you can see there, we got some investment from companies like Suncor and Mitsui, and at the beginning of last year, also Shell and British Airways. And we are using those funds to build actually the first plant in Europe. Very exciting. We received also funding from Horizon 2020. The project's called Flight. It's the one you see in the middle there, with a target to have this aviation fuel plant up and running in Europe in 2024. And then with the funding from the Lanzajet spin-out, we'll also be building probably about 6 to 7 other plants in Europe, as well as in the US and in Asia. So just a very different part of the business. On the left-hand side there, where you see the aviation part, that's just, as I mentioned, we have two processes that we've developed and patented. One is biological, one is chemical. The first one is ethanol, the gas fermentation to ethanol and other chemicals. And the second one is basically that ethanol to jet and diesel fuel. And we've worked in the same way in the consumer goods industry. So the project you see in the middle there was announced probably sometime in 2020. That's a project where we worked with downstream partners TotalEnergies and L'Oréal to produce the bottles that you see there, which are targeted for the hair care range at L'Oréal for a launch in 2025. L'Oréal say that they are converting their fossil and bio polyethylene to what we call carbon smart polyethylene, mainly based on the improvement in the environmental profile. Obviously, we're using waste as a feedstock. Waste is a resource that has some advantages over other feedstocks. And TotalEnergies then convert that ethanol to ethylene and polymerize it to polyethylene for L'Oréal to make into these, I hope you'll agree with me, very attractive bottles. Completely different market and application. We work with Unilever, and Unilever have launched 3 products in the last 12 months, an Omo detergent in China, a Sunlight dishwashing liquid in South Africa, and the Coral laundry detergent in Germany, all labeled as containing recycled carbon from emissions or from CO2, which seems to resonate well with consumers. And here we work with a company in India, India Glycols, that does the conversion of the ethanol to the surfactants that Unilever used to formulate in those detergents. So I hope you're getting a feel here for the variety, because it was said before, and it's often said in CCU, or carbon capture and utilization, but what about the markets? Where is the value? Well, we are finding that in terms of carbon capture and valorization in these types of products, not just aviation fuel, but the ones I've shown here, are highly valued in the market today, and people are willing to pay more. Just one thing I wanted to mention, in aviation fuels, we know from the airlines that they are willing to pay more. And I don't know if you've seen But recently, a few airlines, I think Air France and KLM, announced that they would charge passengers a surcharge for the use of that fuel. So they're passing on some of that cost to the consumers, which is probably a good thing to do. But here are just some other applications. 2 launches in the textiles industry last year, one with Lululemon, a sports brand, a Canadian brand, where again, there's a multi-step conversion process with downstream partners. The Lanzatech Carbon Smart Ethanol is converted into polyester fibers. And in the middle there, you will see that actually Inditex Group, the Zara brand, launched a capsule collection in the market in December, in fact, on December the 13th, with those dresses for the holiday season. And something I have not seen in my 40 years in the chemical industry is the label, that therefore it's on the slide, that shows the story of recycled carbon emissions and repurposed carbon emissions in those dresses. And if you didn't get one in December, you can look forward to March, because there will be another launch, spring launch of these dresses with the carbon smart polyester fibers. And on the right-hand side, and this isn't an exhaustive list, but we also work with polyester resins with downstream partners for packaging, polyester packaging. So that was what I was going to say about what we do, who we are, and the kinds of applications we've developed. So I hope I've convinced you that there is a future for carbon capture and valorization. It's an exciting future, and that actually we can say today even that consumers value these types of products. It's effectively a new type of carbon. Thank you.
Babette, thank you so much for the presentation and the insights on Lanzatech. Again, I would invite you, come join me here for a couple of questions from the audience. And maybe one question from my side. We heard a lot about the activities and the plans that are going to be established also in Europe. Can you share maybe some projects which are coming in the year 2022 for you, with a focus on Europe? We heard about different industries, fashion, aviation. Is there like a focus for Europe, or do you try to tackle all different fields also in Europe?
Very good question. I hear you've asked that of the previous speakers, because prioritization is a key challenge. I think we are going to focus forward on both the sustainable aviation fuels and the chemicals as sort of separate business units, even though we don't call them as such, and prioritize applications within those where there's value in the marketplace. So we will be split between those two things, but very different kinds of businesses, because obviously sustainable aviation fuels is large volume, lower value. One thing I forgot to say, which is important actually, because it was mentioned earlier about biogenic carbon and different types of carbon. Lanzatech's carbon fuels are called recycled carbon fuels. And one of the reasons for the delay in the plant here was, of course, the fact that we had to get recycled carbon fuels into the Renewable Energy Directive. And any of those of you who deal with policy will know that that's not a simple activity. And of course, the regulations continue to evolve. But what I wanted to mention about the plant we're building here in Belgium with Arcelor is that they have done a separate parallel project called Torero, which will torrefy waste wood. And they will be feeding the blast furnace with that waste wood, with the torrefied wood. They call it biocoal, to replace much of the fossil coal that feeds the blast furnace. So actually some of that carbon coming out of there will be biogenic, which is interesting. I was not familiar with the steel industry, but if you can imagine, you don't have to be a chemical company to produce chemicals. You don't have to be a fuel company to produce fuels in the future. You can be a waste management company, or you can be a steel company. So, sorry, I hope that answered your question.
Perfectly. Thank you so much. There's also one question coming in from the audience. It's a longer one. I'll try to read it. Lanzatech already has several plants operating at commercial scale, but also a lot of technology in development. What are the key factors that brought success for these commercial scale plants?
Mm-hmm. Well, they are many, but as you can imagine. But really, I think it's, apart from the persistence and patience, Lanzatech has done many demonstration and pilot facilities, and I look to the Port of Antwerp here. Great job to put these NextGen district and the demo facilities, because that really was key to proving the technology. Because when we started out in 2005, as you can imagine, people did not believe it was possible. I mean, this sounds crazy. You're going to take carbon from gases, coming from industrial emissions. So Lanzatech actually did a lot of demo and pilot plants all over the world, some of which didn't turn into commercial plants. but they enabled us to prove out the technology, gain the confidence of investors, and gain the confidence of the marketplace. And of course, the other thing that's already been mentioned is money and funds. We've been very fortunate. We've raised just over $500 million since the outset with a very, both strategic and financial investors, so chemical companies, energy companies, financial investors, and that has enabled us to go forward and build these demo plants and to build the first commercial plant. We've also benefited from a lot of government funding and are working closely with the European Commission on Horizon projects and Innovation Fund projects to continue on that.
Okay, thank you so much. Maybe one last short question, short answer. What is the current TRL level of your technology for ethanol production from syngas?
Do you think they're meaning syngas from municipal solid waste? Possibly. I mean,
Possibly,
it's TRL
yes.
9. It's commercial. I mean, as I said, we've been running in China for the last 3 years. So it's effectively commercial.
Okay, perfect. Short answer. Perfect. Thank you so much. Thanks for coming. Thanks for sharing the insights. Okay, welcome back. I hope you had a chance to refill your coffees. Now, the final part of our today's Innovation Day is going to start. We will continue with a panel on the topic of accelerating circular technologies. And I'm very happy to have amazing panelists with me. I would like to introduce them and give them a chance to introduce them by themselves. But we have several representatives, for example, from BlueChem, from Triple Helix, and from Total Energies. We also, unfortunately, would have also invited Tine from Essentia. Unfortunately, she couldn't make it today, but I think we also have like a good round with the 3 people next to me. And with that, to start with an introduction of each of them, I would like to hand it over to Leentje with a quick introduction about yourself, what you do, what BlueChem is about, and also how this is related to what we've learned today about the topic. Thank you.
Yeah, well, thank you. I'm Leentje Kroes. I'm manager at BlueChem. BlueChem is the incubator for sustainable chemistry. We're located here in Antwerp on the south side. With BlueChem, we support young startups and scale-ups active in sustainability in any way they need, from finding them or providing them with a good location, with labs, offices, flex spaces, but also with all kinds of administrative support, advice, anything that they need actually. And we want to help them get their technological innovations to the market as fast as possible. Because we do need a lot of innovation, making sure that we can make the transition towards a more sustainable society, a more sustainable industry. And the startups that we help and house, they have a lot of those innovations that we're waiting for.
Thank you so much. Welcome to the panel. Next up, Steven, you want to continue?
Yes, obviously. Very happy to be here. Thank you. So my name is Steven Peelman. I'm CEO and founder of Triple Helix Molecules as a Service. It's probably the world's first industrial operational holding fully dedicated to the circular economy. What we actually try to do is material reincarnation, so closing material loops by building recycling plants, logistics hubs, digital solutions, application development, and even funding solutions. And the first initiative is our SurePure polyurethanes recycling plant here in the Port of Antwerp, NextGen district. And obviously we live in BlueChem. This is our office. So yeah, very happy to be here.
Amazing. Thank you so much. And last, Pedro.
Well, good afternoon. So my name is Pedro da Silva. I'm the technical director for the Antwerp platform for Total Energy here in the port of Antwerp. It's a platform with refining, with steam crackers, and we also produce polymers. So Total Energy, most of you know, it's a company that delivers all kinds of energy. It's an energy provider, let's say like that. And then the relationship with what we heard today, for example, there was the first presentation from the port of Antwerp for NextGen, where we're speaking what is circular economy. We are in all the things that were mentioned there. We speak about recycling plastics, carbon capture. We are studying this, and we are also digitalization. Or even we spoke about, there was speaking about hydrogen or electrolyzers. These are things that we are studying.
Perfect. Thank you so much. Thanks a lot for the introduction. And I think what is really nice that we have different stakeholders. We have, I would say, enablers. We have startups. We have large corporations who all play a role in the transition and in the topic. Just for logistics reasons, so we have a screen here So there are a couple of questions coming up, so you can also take a look here. I would like to start with with the very first question. The importance of accelerating circular technologies. Is this something we need to push? We need to double down on, or would you rather say it's going already in the right direction? Maybe we can start, Lintje, with the first question.
First of all, I hope we're going in the right direction. But I think it's safe to say that the efforts we're making today, they really need to pick up speed. We've seen it over the last years, the things we see in the news, the weather changes, the conclusions we had at the COP. We are doing the right things, but we really need to pick up speed. So I hope that the answer will be unanimous that yes, there will need to be an acceleration of development of circular technologies.
Something you would agree on, or?
Yes, I absolutely agree. I think we will get to the 2030 goals, but 2050 is a different story. And a circular economy has nothing to do with the linear way where we've been working in the past. So it's a totally different ballgame. It's not just about the technology, it's a different business model. You need to be circular on all aspects of the story. And this needs to pick up speed because we're still looking too much at the circular economy through a linear lens. And that will probably not work. It's not about more or less, it's about something completely different, in my opinion.
Okay, thank you. And speaking on behalf of a very large organization or a very large corporation, how does this affect, for example, regional activities like here, or is this something which has to be global and has to be pushed?
So, if I may, I agree that we are in the right direction. And then we were speaking about 2030, even 2050, when we look at the objectives that Total Energy has announced, or what Jan said about ENGIE, it's tomorrow. Huh? So yes, it must go very fast. And these ambitions are so high that there must be some acceleration. So it has an impact worldwide for sure, and it has impact in our plant because in order to be on time, we have to build plans and we have to go in all these directions to meet the targets of our company.
If you to raise your microphone a little bit so everyone is able to understand. Thanks a lot. Maybe following the question and coming back to the different stakeholders and from enablers to startups, can you basically connect the different stakeholders? And for example, we heard a lot about developments which are also happening here in the NextGen district. Is this something which is moving towards that goal, to also being able to connect several stakeholders, also providing resources, financial resources, but also space, for example, to startups or to larger players? Is it something which is going into that direction already?
Please, Steven. Well, yes, of course, it is going in that direction. But if you ask me, what do we really need to make sure that we can accelerate even faster is, financial means. We live in a sector, or we work in a sector where it's very R&D intensive. The R&D takes 5, 10, in some cases up to 15 years. If you make a quick calculation, if you would just employ like 2, 5, or 10 people for that amount of time, what the cost would be. They're also high-profile people. You need to find the talent as well. But it takes a lot of time and money to do that, and the risk is very high. It's R&D. Not everything that you research comes up with the right answer or with the right technology, a technology that works. So we need funding for that. And there are multiple options. And not everything needs to be subsidized. There needs to be a mix of good government aid, subsidies, but also with private investments. The banks need to be on board. It's a mix of different things. And I'm happy to say that in Flanders and Belgium, we have some very good R&D subsidies. So if you do early stage R&D specifically, there's quite a lot of possibilities for funding. But what we do see that is missing is financial stimulation for more upscale activities, so higher TRL activities, pilot plans, demonstration plans. We've heard it here today, I think 3 times. Demonstration plans, pilot plans, we've heard figures of 50, 60, 100 million euros. And it was just said by Babette, several of their pilot plans, they were put up, but they didn't actually lead to commercialization. There's still a big risk in doing a pilot or a scale-up. And that risk needs to be acknowledged, and then it should come with some subsidy or some aid from the government.
So you're, to understand it or repeat it with my own words, the financial resources are should come more from the public side, or also from different sources like the corporation?
Should be a mix. Yeah.
Yeah, I would say a mix, huh? And then, but we even can compare some countries like the Netherlands, for example, where they have lots of support for this kind of subjects. And we see even within the company that some projects are being made there and not here because there are more supports there. But it must be a mix of it. Huh?
Yeah, I agree. I mean, we're a startup, but we need 70 million to build a pilot plant. This is not something you just ask a bank. So there needs to be a viable business case. It needs to be investable. And if it is investable, you can build an ecosystem with a couple of partners who can make a value chain that is worth something. And then it becomes a story that you can go to different partners, to banks, to professional investors, even to the public itself. And of course, subsidies is important, but building an ecosystem is probably the biggest benefit of having something like NextGen District, like Bluechem, and also the work that the Port of Antwerp is doing in integrating a chemical cluster and a port, which is crucial for us.
So those are some challenges you face as a startup, like the financial, able to get financial resources. But are there any other challenges? I mean, this could be maybe a question also for Bluechem, which is maybe a little bit lacking to be able to let startups grow and to scale, especially.
Well, what we also see is the challenges that we're tackling or trying to tackle, that the companies are trying to tackle, they're very big challenges. And it's not something that one company can solve on its own. There's not one company in the world who says, I'll now make an invention and it will solve all of our problems or our climate difficulties. No, it doesn't work that way. So cooperation, working together will be very important, and you need cooperation from bigger companies with the smaller startups and scale-ups. You need the effort being put in by governments, making sure that legislation and the framework is there to support the new ideas, the new technology, and not work against them. You need the banks and the VCs to put up the financing. They need to be open-minded. They need to know that these technologies take a while before they give a return on investment. And all these different players need to come together. And it will take some time, like Steven said, for the ecosystem to come together. It's not just putting everyone around the table and they'll all agree that new technology is needed, R&D is needed, and we need to do something. But to actually get it going on out there, making sure that plants are being built, efforts are being made, that's a different story.
Yeah, if ever you believed in a hockey stick, there's no such thing in a circular economy. So it takes a little bit of time. And stability of, let's say, the regulatory framework, that's a difficult thing, of course, in a world that's moving so fast and changing so fast. But this is also something that you absolutely need, ideally.
Okay. And from the Total Energy side, do you see like a shift also in, adopting or being more open towards, let's call it maybe startups or early stage companies who could also help you achieving on the journey towards being more sustainable and circular?
Yes, I would say so. Okay, not in the plant that we have here, although we are a plant that is open to many pilots, and we started already a pilot on plastics recycling. We can maybe speak about it a bit later. But if you look at Total Energy, we are just installing now a research center of new energies and electricity in Sarclay, near Paris. It's in the middle of an activity zone with startups and innovation startups. So it's really in the middle of what you are saying. And we also are restructuring a bit a lot, in fact, our research and our tech services. We are creating one big tech services with 3,500 technicians, scientists, engineers. It's in one structure that is there to help the business units to be aligned with the objectives of the group that are very ambitious. So we are already putting all this together. And this one tech, we will work with the startups and innovation startups for sure.
Okay. I would maybe also comment a little bit what you said regarding the venture capital side. What might be arguments to convince them to put more money, to invest more into more riskier startups or more riskier cases instead of continuing where you have like a good ROI and a good also return on invest? Are there like arguments you can think of which could stimulate being the more proactive?
Well, we're happy to hear because we're always looking how to convince the VC. So if you have any ideas, please share them.
Do you have any?
well, maybe the start. Well, I myself, I don't do the pitches, but the startups will. I hope that they have some ideas, and then I'm looking towards Steven. But yeah, it's very difficult. I've heard it from every startup that's in Bluechem. Also, startups that we are connected to through Essentia, our shareholder, or Catalysti, the innovation cluster in Flanders. They all say the same thing. It's very hard to convince investors. Although you're doing something that you can show will bring return, but be it in 15 years or maybe later, and you're doing something that's sustainable, that's green, that's really improving the planet, say it in those kind of words, it's still difficult. So whatever we can say to convince them, please let us know.
Yeah, I think the first and foremost is a business case and the multiple that you're going to get at the end, and that will not go away. And actually, it doesn't need to go away, because that needs to be it's the only way that you will get a systemic change, that if there is a business case, if it's socially acceptable, and if it's, of course, in terms of ecology, also the right solution. So that is something that doesn't necessarily need to go away. The question is there something else? And I think the timing is right. Everyone knows that the world is changing. So if you have an alternative investment that is roughly the same return on investment, but is not green, so to speak, that will become much more difficult to sell in the future. But obviously, that's if there is alternatives. The next question that you can ask yourself is, if you go to a VC, when do you go to a VC? For which chunk of the money? In which level of maturity are you at that point? And I believe in blended formulas. If you need investment money, then there's a point in time where you need to go to investment from VCs, but there's many other sources that you can use in the meantime as well. And that helps, because they all, tag along at one point.
Do you want to share a little bit, because you're also one of the first who enter into the NextGen demo, share a little bit about Triple Helix and which stage you are and what is coming up for you in the future?
Yeah, so what we're actually trying to do, so we raised a little bit of money 2 years ago to fine-tune the idea, and it was basically a concept at the time. So early 2020, January. I didn't know what was going to happen 2 months later, of course, but if you jump, you have to stick with it. And so now we're at the point that we got the concession confirmed from the Port of Antwerp, end of December, 1st of January. So you have basically an asset going forward. It helps the discussion with venture capital, for instance. We have the plans of building the plant. We have first agreements with commercial partners to either supply material or take off material. You are in the permit process, so to speak, nowadays. So you are a little bit further down the road, so it becomes very tangible. And if the technology is clear enough to everyone in industry, and there is a certain need, and there is clearly a need in the polyurethanes industry, then you get more and more support. And so it's not about finding the money. There's a lot of money out there. It's having the right story and asking the right amount of money at the right point in time. That is basically the difficulty. And when you're a startup with no professional experience, not having been on the other side, so to speak, it's going to be very difficult. If you used to be within the corporate life and you know how decisions are taken, it obviously helps to sell the story, because that's basically also part of the deal.
Yeah, okay. I see. Are they, maybe a question towards Bluechem, in general, also a lack of startups coming into that space or into the market? Or is it then more the follow-up? I mean, after you successfully, installed your company and trying to get customers, trying to raise money? Or is it really also a problem that not a lot of founders are entering into that space?
Well, we have seen over the last 3 years, because Bluechem has only been operational for about 2 years now, and we had 1 year of, let's say, a workup or a pre-startup period. But we've seen that there are more startups in chemistry or sustainable chemistry out there than we initially thought there were. Every year, I think last year, there were somewhere around in the early 40s, 43, 42 new leads that we discovered. So startups that were that had first initialization in the past year. I think that's quite a lot for our sector. And we even expect more in the future, because some of you will know that there's a new program called the Moonshot Flanders program, which is focusing specifically on enabling technologies for a carbon neutral industry. So we do expect that from the Moonshot Flanders program, more startups will follow. What we do see is that startups, although startups are they move fast, but they grow slow in our sector. As I said, the time that they start up first R&D activities in the lab up to the point where they actually go to commercialization, it's about 10 years on average that it takes. And I don't really think that that's something that you can speed up. You can't just cut that time in half. It's very risky doing innovation and R&D. You go down several roads where you know that three out of five or something won't end up in the result that you're looking for, but you need to go down them to find the right one. And in chemistry, we do take a lot of precautions. We consider safety very important. So we don't rush things to make sure that we don't cut back on safety. So yeah, the amount of startups, that's okay. But any means that we have to make sure that they go to market as fast as possible with the new technology that they develop, that's something that we're trying to establish.
Okay. Do you want to comment on that or? Your microphone.
Sorry. I fully agree. And then just to add for safety and environment, because some of these new technologies also can have an impact on the environment. Or alternatives for CO2. If you speak about, for example, burning hydrogen or blue hydrogen or green hydrogen, okay, it also creates more NOx, which is also a problem for the environment. So all this has to be taken into account.
Okay. And now we talked or touched on the topics of, let's call it roadblocks on the public side, a little bit on the financial side, but can you think of also roadblocks, I mean, on a technological side, on an acceleration side in general? I mean, speaking on behalf of a large organization.
Yeah, when you have a large organization, it's never easy to work on technologies that are not mature. So, but I think times are changing, and today with the challenges we have in front of us, we cannot not look at this. So the mindset is changing. In my company, is changing. We do have to look at these smaller companies, and then because many ideas will come from this, and we will not do it alone. And we see we have to collaborate for most of the things we are looking at, be it carbon capture, carbon usage, utilization, hydrogen, and so on. We don't do it alone. We have to collaborate with different stakeholders.
Can you think of any other roadblocks?
Yes, I agree, and I think the term open innovation has been mentioned a couple of times today, and it's absolutely crucial that people start working together more and more, and not just in a let's say a one-on-one sense of the word. So yes, forming these ecosystems and allowing new partners, even pre-competitive new partners in industry, can help because they can take on what the rest has difficulty to do sometimes. For strategic reasons. So that's an interesting point, I think, that we might stress. And then a second one is stop with greenwashing, because this entire world of the circular economy that struggles at times to have early returns on investment is dependent upon credibility. And if you read some of the websites in industry, then every problem in the world, including being lovesick, has been solved, and that's just not true. So we're fooling ourselves at times, and it destroys credibility of the industry at times. So we need to make sure that we don't do that.
Okay, well, indeed, I would agree. The talking about open innovation and talking about partnerships, I think there's also something which Plug and Play is convinced that this will help to accelerate. Is there already like enough activities happening to foster and to build partnerships, or what is lacking here?
I think it's experience and trust. Working together, not in a customer-client relationship, but really on an R&D level, it really you need to really trust each other. You're as a company, you're exposing part of what you're doing, who you are as a company, and that takes time. Building the trust that you need to do that just takes time. And there are a lot of great initiatives to stimulate that. I've mentioned some already, the sector federations like Essentia, the innovation clusters like Catalysti, the port, the city, they're doing a lot of events, stimulating activities to make sure that the bigger companies and the smaller ones are finding each other. But it will just take some time for all those parties to come together, for to them to spot opportunities as well. And yeah, like Steven said, if you meet each other today, but you meet each other again in 6 months, in many cases, a lot has changed already, especially if you're dealing with startups. So yeah, you need to come together frequently. And yeah, over the last 2 years, Corona definitely has not helped in that aspect. Let's hope that coming year will already be a bit more loose and we will be able to see each other more live. That does make those kinds of talks a bit more easy.
Yeah, I agree. It's a people's business. Innovation. The technology might be the right technology. People in technology will talk to each other. They love to talk about technology. But it's indeed people who can make it happen, who can take the decisions, who can fund decisions. They have to get along as well. And so personal contact is very important. So everything that underpins and tries to develop these contacts is absolutely welcome.
Perfect, thank you. We're also getting questions from the chat. And I would read one which is coming up here. Are the customers willing to accept higher TR project despite higher prices?
I can maybe answer. Okay, I don't know for all the cases. I don't know for all the cases, but I will give an example if I may. We in our platform we started with a pilot to recycle chemically plastics. There was a presentation, I think, from Indaver about this subject. So we started some recycling. In the beginning, it was a pilot. So I had my teams making the project to install all this. Today, it brings value. When we sell, in the end, you recycle plastic, you make again plastic. This plastic that we sell, and when we look at the business case, there is a business case. So yes, some clients are ready to pay. It depends on the subject. On this specific one, yes. So, and then there was an example for the Air France and the KLM that they will put it in the price of the ticket, and I think people would be ready to pay for that if you explain why it is.
Okay. We are slowly wrapping up. Maybe questions from, or if you reflect a little bit on what we learned and what has been shared today, is there something you would address or comment on based on the different speakers and the different contents today?
Well, I think we've seen some great examples on when people do collaborate, companies do collaborate, what can be achieved, both from bigger companies and smaller ones. So I think we need to keep pushing in that same direction. And for the people who are at home watching, following the session today, well, just reach out if you've seen anything that you think sounds interesting. Reach out to any of the speakers or the people who organized the session or any of us panelists, because I think the message is clear. We are open to working together and we are all looking to move forward.
Steven?
Yeah, I agree. I mean, what has been mentioned earlier today, what has been shown, just stresses the fact that we just need to be open and work together, because there's not just one solution in solving waste issues or solving the energy crisis or climate change. There's a lot of aspects going on. There's a lot of people trying to do good stuff. And if you think in ecosystem terms, it's just trying to explore what your business is and where you can reach out and be open to others doing exactly the same and trying to set up stuff. And instead of writing what other people should be doing, do something yourself. That's where it starts.
And Peter, what do you think?
Okay, I want to repeat the same thing. In fact, it's not one solution that will solve all our issues that we have today. It is multi options. If you look at energy, electricity, it's not going to be only wind or only solar. It will be a panel of different things. The same for circular energy, for everything that we have been talking about. And then the second one is open-minded. We have to change some of the old way of thinking if we want to go forward.
Okay. One last question, short question, also short answer from each of you. If you can name really one thing which will accelerate a shift towards a circular economy or also circular technologies in general, if you name one thing which is really precise, what would you say? You can think for a couple of seconds and then I pick one and then we make the... You can go first.
The business case is very important, because you cannot go forward if you don't have a business case. Okay, maybe you don't need to have it from the beginning, and in the beginning it's difficult, but business case is very important, which means you need different stakeholders, what you were explaining a bit earlier. It's not only the companies or the startups, it has all the stakeholders must be in. Authorities, banks, and so on and so forth.
Okay. You two are left. Who want to go first?
I might steal yours, Steven. I would like to stick to cooperation. It's a circular economy. There are a lot of different players in the circle, and you need all of them to be on board.
For me, it's transparency, because it allows you to collaborate, but it allows you to take the right decisions, be informed on what's really happening. So transparency, market dynamics, transparency in logistics, and so on and so on. That's what it boils down to, and then you can act.
Wonderful. All right. With that, we will close the panel. Thank you so much for coming. Thank you so much for sharing all your insights with us. We will now continue with slowly the closing remarks. And if you listen carefully, we will also hear again a little bit how you can apply and get involved in the NextGen district and NextGen demo. And for that, I would like to call Marleen on stage again. And for our panelists, I would ask you to leave the stage maybe on this direction. And then with that, whoops, careful, the cable. And with that, handing it over to Marleen. Thank you.
Thank you, David. And hi again. I hope you all had an interesting afternoon where you could learn how we accelerate circular technologies here in Antwerp. And of course, that you are convinced to be part of it too. So if you want to submit your project proposal for NextGen demo, this is what you need to do. So first of all, visit our website. It's a page on the Port of Antwerp website. So it's also easy to find through the search function if you don't find the direct link. There you will find then a checklist, which is actually the list with the questions that need to be answered for the project proposal. Prepare your answers then first according to this list. And if that's finished, you can submit your application through the submit button on the website. Important there is to fill in the answers all at once. So if your project fits the scope of NextGen demo, you will be invited to pitch your project, and then we will evaluate the project based on the written proposal and the pitch. And after a positive evaluation, we will set up a plan together to realize your demonstration unit at NextGen demo. So the deadline for submitting is 28th of February. If you still have questions, do not hesitate to contact me. And I hope, of course, to see you in the future. And would now like to give back the word to David for the closing remarks.
Thank you so much, Marleen, for sharing how you can apply and how you can get involved. For the closing remarks, I have the honor to have Pete with me. Pete, feel free, please come on stage, take a seat. And we don't take too much of your time before we end the Innovation Day today. First of all, Pete, thanks for coming. Thanks for being here. I would maybe invite you to introduce yourself and then also share your thoughts on the day-to-day, what we have learned, your perspective. I think this would be valuable. Thank you.
Thank you, David. It was really wow, I would say. For the first Innovation Day of Plug and Play Maritime here in Antwerp. So I'm working for the Port of Antwerp, responsible for innovation enablement there. So I was one of the drivers also to start with Plug and Play last year. And I think it started rolling now. And I was really inspired in the last 2-3 hours to see large companies who have a clear strategy where to go to that zero carbon economy. Still a lot of projects in pilot phase and so on. Very nice to hear from Indaver also that you need, for instance, purification of the waste cycles, because people forget that. Yeah, we take some waste and we make chemicals out of that. No. I think these guys, they do things, they learn a lot, but they also guide other companies where to go. Also, Lanzatech, great to hear that you're coming out of the Valley of Death. I think it's maybe 7 years ago. I have seen a presentation from you. It's a complete different story now. So you have really operational production sites happening. So maybe a word which I didn't hear this afternoon was inspiration. I think we need to inspire people because you have to take them in the story. We go to a different world in the coming 10, 20 years. It will change a lot. And we have to take people there that we can reach that and it's achievable. And I think all you are very smart people who can do that. And you're working on solutions. So please also take time to take people with you. Also the public, students, politicians, very important to have that. Because I believe every smart engineer today, the only thing he would like to do is to set up to build a startup, to change the world. So we should support that young talent. And I see also how much knowledge there is present here in our small area. I think a massive amount, good universities, good industry. So let's build on that. And building ecosystems, that's not easy. That's hard work. It's a métier. You need focus, you need money, you need partners who are prepared to work with that. But I'm very happy to work for the Port of Antwerp, who is supporting that and having that open innovation, because I think Antwerp as such is a district, an innovation district, having Blue App, which will open within a few months, having fundamental research, Blue Gem, which is on applied research, having NextGen demo, where can you build these demonstrators, and of course having that massive integrated chemical cluster, one of the largest in the world, on 4 or 5 kilometers from each other. I don't think anywhere in the world you have something like that. And it's only beginning now. So it's getting filled up very fast, NextGen district. So I'm looking, Dries, when the next phase will build. Let's see how NextGen demo comes up. But I hear every week companies who are interested. So I think there is a potential to build that new economy here in Antwerp, and really excited to be part of that.
Wow, Pete, thank you for that inspirational closing remarks in the end. Thank you very much for sharing this. Also for involving the speakers, the attendees today. And now it's time to wrap up the session, wrap up our Innovation Day. On behalf of Plug and Play, of course, we would like to thank you, everyone who was involved, especially to the Port of Antwerp for also hosting this in their port house, the people behind the camera, our speakers, the audience, our panelists. It was an exciting and entertaining 2.5 hours. I think we managed almost to finish on time. And with that, I wish everyone an exciting afternoon and a great rest of the week. And with that, thank you and hopefully see you soon in person.